someplace in my mess here, unless I got rid of it. Yeah, I did. All right. You've all got a copy of this. And I will open it with Notepad. But this is our schedule. So last week, I lectured on chapters 1 and, well, really 1 and 2 were on the same day. And then 3, okay, we had the lab, we did the hands-on. This week, pretty much the same kind of thing, except I'm flipping these two. 5 today, 4 tomorrow. Wednesday we'll have a pretest. Now, much of the stuff I'm going to talk about today and tomorrow is not on your next test. But it's stuff you have to understand as we go on. Does that make sense? The pretest that I will give you Wednesday will be similar to the test that you will take on Friday. And Thursday will be a lab. All right? And next week, we're already into November. Now, I don't know if this is exactly going to work like this or not, but that's the way I've got it planned. 13, 14, and 16. No homework on those. No tests on those. You all heard that, right? No labs on those. So why are we going over them, Jeff? Because the material that's in there is stuff that you'll need in order to be able to start going through the stuff in the other chapters. All right? Okay. So that said, let's jump right into Chapter 5. Chapter 5 is on testing and debugging a JavaScript application. As they mentioned right here on the top of the screen. As you build a JavaScript app, you need to test it to make sure it performs as expected. Now, the first thing they're going to talk about in here are the 3 types of errors that can occur. All right? JavaScript is an unbelievably forgiving language. So the first type of error that they show in here that they'll talk about in just a minute is called a syntax error. Imagine that, let's say that you're in 2nd grade. I know that's a ways back. But imagine you're in 2nd grade and it's the first day of school. And the teacher says to you, what I want you to do is I want you to write a 1-page story on what you did this summer. You with me? Okay. So Angie's writing away, and she gets done. She turns it in, and it's real good, except that it's a whole page, but she put it all in 1 sentence. Probably the teacher won't be real happy with that. You know what I mean? So what she's doing, in a way, is she's breaking kind of the rules of the language. There are certain times when we are writing things that will use commas. There are certain times you might use a semicolon or a colon, etc. Programming languages work the same way. So syntax errors are when you violate the rules of the language. Again, one bad thing about JavaScript is it lets you do it all the time. If you don't put any semicolons in your program, typically it'll work. You don't want to do that, and there are times when it won't work, but it just says, oh, you probably meant to put a semicolon there. Okay? We're using that use strict, or at least I've told you to use it, and I want you to continue to use it. That makes you a better programmer. All right, so that's the first type. The second type is a runtime error. It's harder to reproduce a lot of runtime errors in JavaScript. If I go through there, if I create a simple calculator, and I say enter a first number, and you put in a 2, and I say enter a second number, and you put in a 0, then we say enter an operation, and you say divide, JavaScript doesn't break. It gives you NaN, or it'll give you infinity, which is technically the right answer. Dividing anything by 0 is infinity. All right? The point is, in most programming languages, if you attempt to divide by 0, your program breaks. And it breaks while you're running the program. That's a runtime error. All right? The third type is the hardest type of error is to figure out. It's a logic error. Because you've got something wrong in your logic. Now let's just look at a real simple example. And let's suppose that I told you to make a calculator. And it was supposed to be a calculator with 5 functions. add, subtract, multiply, divide, and modulo. So you entered in two numbers, you hit a button that did one of those operations, and it gave you the answer. You with me? All right. And really, the code for that would be pretty simple. It really and truly would be. But let's say that you did your add, you did your subtract. And literally for the add, all you have to do is say something like you pass in A and B, and you say return A plus B. Okay? Now for the subtract, it should be return A minus B, but you accidentally put plus in there again. So you've got plus both for your add button and your subtract button. Make sense? That's a logic error. Logic errors are typically the hardest type of errors to find because what happens is, and it happens to everybody, as soon as you start coding, you start to think you're infallible. I literally have had people before in the past. I remember having a young lady come up to me years ago when I was teaching in Wisconsin, and she said, I don't know what the problem with this is, Mr. Scott. I saw it right away, but I don't like it where, oh, that's right there. But I looked at it, and I looked at it, I said, oh, well, I think it's in here. And I tried to let her find it. She said, what do you mean? I said, well, look in this area. And of course, she found it. She goes, well, I didn't do that. Somebody did. And unless you walked out for a minute to go to the bathroom or get a drink, and somebody went up to your terminal and put something wrong in there, yes, you did. But it's hard for all of us to think, oh, geez, I made that error. I should never have done that. But we all do it. Everybody does it, whether it's in programming or something else. All right, so those are the three types of errors. We'll look at some common JavaScript errors. Planning test runs. All right, and we'll talk about the difference between testing and debugging in just a minute. All right, and then we'll talk about using the Chrome developer tools. I've already talked a little bit about those with you, but we'll look at them in a little bit more depth and breadth of coverage. All right. Then we'll talk about other debugging mechanisms. Now, one thing you may or may not remember, but I showed you this, I think, last week when we looked at one of the programs. Something didn't work, so I put a bunch of alert statements in there. That's another way to debug. When you debug, when you test, you're trying to find errors. When you debug, you're trying to fix those errors. All right, so they very much go hand in hand with one another. So, when you test an application, you run it to make sure it works correctly. Now, I think you'd all agree with me, if I did a calculator, it is not physically possible for me to test every number or every two numbers that I might input with all five of those operations. That would be into the, well, it'd be more than billions. All right? But you get the idea. So you want a representative sample. When we talked about on the test, remember when you had that thing for the venue, and it was if you were greater than or equal to 21 years old? Well, what should you check? You should check a number that's less than 21. You should check a number that's greater than 21. And you should check 21. Does that make sense? So you should check something that falls lower than the range, higher than the range, and right at the range. All right. If you haven't put any code in to handle non-numeric input, and you put something in non-numeric, the program's just probably going to end up giving you, if it's a mathematical thing, it'll give you NaN. All right. Well, what does that mean? That means that typically you haven't tested your application completely. It should be set up so that any person can run it. So again, these are the three types of errors. Syntax, violate the rules of the language. Runtime, as it says, the page has been loaded in the browser and it's running. Logic, as it says, it's in the logic of the coding. So when we look at these, it says here, it's an application that's going to give you a logic error. Well, I don't know about you, but if I was able to invest $10,000 at 3.5% for 10 years and get back over $1 million, I'd do it. But there's an error in there. Sometimes it's very apparent when you go and run your program, you've got an error. Not only that, sometimes when you do it long enough, you know right where the error is. Tomorrow we'll start talking about how to break your program into pieces, into functions. That makes it even easier. You get a little more code, but you are basically segregating each job into its own function. All right. So in other words, If it's a calculator, I might have an input function. I might have an add, a subtract, a multiply, a divide, a modulo, and an output function, as opposed to putting everything in main. Main then becomes a driver. A good driver really is pretty much like a good supervisor, where she or he knows who to delegate work to. All right? And that's pretty much the job of the driver. That is actually the job of main, is to do that. To do as little processing in main as possible and break it up into different routines. So as it says, the goal of testing is to find all errors before the application is put into production. One thing you don't want to have happen, now in the 4th semester here, you take a class in Android. All right, and one of the things that we're doing in there is almost at the beginning of the semester, we're writing a fairly simple app. And then we're taking it and immediately we're actually putting it out on the App Store. It's going to be free, but you'll have something out there. The point is, you don't want to put something out there. Let's say you just created the world's simplest calculator. All right, somebody puts in 14 and they put in 10 and they tell it to multiply and it comes back with negative 37. Well, it's pretty obvious you've got some kind of an error in there. You want to find that error when you're testing. You don't want to take this and give it out to somebody and have it break. Now, this Friday, if you remember, this Friday coming up, the 30th, pass 1 of this Arrow Bridge rescue is due. And I'm going to take everything that I get sent from you guys and I'm going to send it off to her. And I'm going to ask her to comment on each one. But one thing you really don't want to have happen is you don't want to have it where, let's just say, one of the links doesn't work. So you want to test it. So whether it's writing JavaScript code or doing something else in IT, much of the work that you do involves testing. Notice the goal of testing is to find all errors. You should look at it, if you find an error in your code, that's a good thing. Better you than someone else. That's about all I can say about it. Then once you find it, you want to get rid of the error. That's debugging. Testing ideally finds all your bugs. Debugging ideally gets rid of all your bugs. Questions on that? We talked about the 3 types of errors. I'm not going to say them again. All right. So here's some common JavaScript errors. I'm not going to read to you. But it is, you start to realize not only you can be, if you're a bad speller, for instance, we'll learn later about query selector, but putting an E in there on the end instead of an O, anybody can do that. One of the big things, though, is capitalization. For instance, we're going to use something starting in a couple weeks, and I think I've shown you this already, but I'm going to put it up again anyway. It's called get element by ID. And that is the right capitalization. Most people are used to when you see ID, you want to make the D capitalized too. Doesn't work if you do that. All right? Or they put all of it, a bunch of it in uppercase or whatever. All right? That's one of the big things with JavaScript is if you're calling built-in routines, you have to call them correctly. All right? What you're actually using here is what's referred to basically, for lack of better words, I don't know if everybody would agree with what I'm about to say or not, but we're using the JavaScript API. An API is an application program interface. It's a contract between you and JavaScript. JavaScript says, Angie, I'm going to let you use this, but you've got to agree to use it the way that I set it up for you, or it won't work. That's what much of the stuff that you do when you're working with programs is. You're working with APIs. So, yeah, you already saw this today. I did it. Remember when I didn't have my one ending parenthesis? All right. This usually isn't a big thing. If you're consistent, remember in JavaScript, your strings can be in either single or double quotes. If you just use one, the only time you're going to have a problem is if you want to put quotes within quotes, then you use the other one. All right. Semicolon, typically it's not going to give you a syntax error, but if it's at the end of a routine, it can give you a syntax error. I already mentioned the misspelling. Be consistent with this. I'd prefer you use this syntax right there. like sales tax. All right. If Jameer were to say to me, you know what, Mr. Scott, I really like doing it like this, then do it like that. All right. I will tell you, you can't do it like that in every programming language. To my knowledge, you can do it like this in any programming language. That's why most people would recommend you do it that way. All right. All right. Problems with data and comparisons. Making sure that the entry is the right type before processing it. Well, again, trying to treat a non-numeric value like it was a number is an example of that. Not using parse int or parse float. We've already looked at parse int and parse float. We will continue to use those. Using one equal sign, I've already mentioned to you, I very rarely use two anymore. I pretty much use three all the time, which again is the equality and identity operator. All right. Problems with floating point arithmetic, if you weren't aware of this already, that if you were to do something like this and take 74.95 and multiply it by 10%, 0.1, you might get an answer like this. When you start to work with numbers with fractional components, they're not exact. Some programming languages handle it better than other programming languages do. Yes, you can round, etc. All right, if I rounded right here, it would be what? 750. Or I could round it if I wanted to 3 decimal places, and it would be 7.495. But if you don't do any rounding, all right. Problems with undeclared variables, you know this you don't have to worry about with the use strict. If you don't use strict, if you look up on the screen here, notice how sales tax right there, little SALES, big T, little AX, and then down here they didn't put the big T. If you don't use strict, it makes a brand new variable right there. So you now have two variables called sales tax, one with a big T and one without. That's just bad programming. Most other programming languages don't let you do that. Next semester when you take C#, they sure as heck do not let you do that. It says here, when the JavaScript engine in the browser comes to a JavaScript statement that it can't execute, it throws what's called an exception. All right? And I've said this before, you probably have heard this, but I mean, if I'm walking down the street and I'm walking down the street and I'm holding the hand of my 3-year-old granddaughter, and somebody comes up and says, wow, what an exceptional child. Most people would say thank you. Would you agree with that? All right? But an exception in programming is an exception to the norm. It's not a good thing. So as it says there, when you throw an exception, it means that something erroneous has occurred. All right? Something that you're going to have to deal with. We're already learning that. You're already learning about is NaN. You're learning about stuff that's out of range, etc. And we'll keep adding on and on to your repertoire as we go on. All right, how to plan test runs. I already talked about this a little bit. The first thing you want to do is you want to test it with valid data. And if you're doing something like this, you want to do it real simple. Notice what they put in there. 10% for 1 year. Well, if they make 10% on $1,000, it should be $100, right? So that should be $1,100. Try a few cases that you know should work. I have watched people put god-awful numbers in as they start testing. The other thing is, and I guess I didn't mention this before the test. Let's assume that it's whatever it was, Friday, and you're doing that test, and let's just pretend for a second that instead of asking you to give you all the numbers that were multiples of 15, between 1 and 100 like you did, you were supposed to do 1 and 1,000. So there'd be a lot of them, I think you'd agree. All right? When you are first writing that and you're getting it to work, don't make your max number 1,000. Make it 100 and change it later. If you're told to test 1,000 things, you're probably never going to test all 1,000. Knock it down to 10 or to 100 or whatever. Does that make sense? All right? I mean, it's just something that you should do. All right. So here it is, where they've tested it with invalid data, and notice they've added something. They've added an alert or something that says you did something wrong. So they mention here the two critical test phases. Number one, test it with valid. Make sure everything works like it should. So again, I'm doing a calculator. I'm going to put in 10 and 10. I'm going to try 10 plus 10, 10 minus 10, 10 times 10, 10 divided by 10, 10 modulo 10. Okay? Now, test the program again with invalid data. Well, if I'm writing a full calculator, and let's say I've even got square roots in there, I don't think you could do a square root of a negative number. Try putting in a negative number and see what happens. That kind of thing. Now, one thing, I'm going to bring this around back to web pages. All right? Because we're going to look at a calculator probably tomorrow, and when we do, it's going to have an interface that's going to be a web page. And you may or may not remember this, but if we set up a text box on a web page, one of the variable types is number. So if we do that, it's impossible for someone to put something non-numeric into our calculator. The only thing we have to really account for then is, well, what about if they put nothing? Okay. But that's a lot better. I don't have to worry about somebody typing in hello now, because it's not going to be possible. All right. So typically you make a test plan, and you come up with a bunch of test cases. All right. What are the problems with that? Number one, not testing a wide enough range of entries. You know, if I did that calculator like I just told you, and all I did was 10 and 10, that really isn't a great test. All right. Or not knowing what the results should be ahead of time, just assuming, yeah, they worked. Okay. Says it's easy to find and fix syntax and runtime errors. That's not true. Usually it is. All right. Sometimes with runtime errors, you don't know what the heck you did wrong. But again, the hardest one are logic errors. So, how to debug with Chrome's developer tools? We're up to page 168, it looks like. All right. So it says there, in Chapter 1, we were introduced to the console panel on Chrome's developer tools. What is that? Again, hopefully you remember. You hit F12. Okay. This is from the book. All right. And when you do that, there are different things that are in here. Elements will actually allow you to go in and see the CSS they have in there. Lighthouse, I don't know what it is. Console, as I've already told you that. That's what we're going to be using. The other one that you might end up using sooner or later is network. Because what you can do with network is you can check the traffic. So if you had a website, you can check network traffic, and there's a few other things that you can do with that. So F12 turns it on, F12 again turns it off. All right. Now, it says here, there's the F12, and that's fine. It says the error message that's displayed is for the first error that's detected, but there could be others in the code. Sometimes fixing one error will now show you other errors that you have in the program. It's just the way it is. And the more complex a program you write, the better the chance is you're going to find an error. All right. So if we come in here, if you look, this is the one they showed you earlier. And this is that future value. Now notice, because I've done this, is NaN, where the second N is not capitalized. So it's showing you where that is. And if you do click on here, it'll even show you the code if you want to look at it. All right. But there's more that you can do with these developer tools than just that. That's a good start. All right, as far as showing you what's wrong, etc. But there's also something that you can put in there that are called breakpoints. We're going to look at this more tomorrow. But the point is, no pun intended, if I go and click over in here, this area with the numbers, it's called the gutter area. And when I click there, usually it's going to put a little circle in. It's probably, I believe in here, it's going to be like a different kind of red, like an off red. So sometimes it's blue, but I think it's in here it's red. And what that means is when you get to that point in the program, stop, break. And what you can do then is you can take a look at any value that's been set before that. That line has not run yet. All right, so if you hit a breakpoint, well, it's going to stop right there. You can put in as many breakpoints as you want to or need to. So you hit a breakpoint, yeah, that's good. I think it's the F11 key. If you hit it, it'll go and run until it finds the next breakpoint or until the program ends. All right. So as it says, click on the Sources tab to display the Sources panel. All right, we'll look at it tomorrow, like I said. Then click on the file that you want to debug, and then click on the line number. Okay. Now these are different things that you can do with your code in this table that's right here. You can hit F11. F11 is designed to run your code a line at a time. Sometimes that's really nice to see exactly what's happening. All right. F10 says run any called functions without stepping through them. What does that mean? It means go through it, but if you've got a big loop, you're looping 100 times, typically it just runs through it once. I mean, if I'm going for 100 times, I don't want to have to sit there and keep doing this 100 times. That would be kind of silly. All right. Step out executes the rest of the function without stepping through it. So the first one, F10, does step through it. F11 or shift in F11 acts like it's not even there. Then there's resume. So if you hit a breakpoint, you want to keep going. I maybe said it wrong before, but you hit F8, and that'll allow you to keep going. You're going to see all these as we go in there. There's also things that you can put in there that are called watches, not like you wear on your hand, but a watch is something you put a watch on a variable. So as your program runs, you can have a little watch window that comes up, and it'll show you the value of that variable as the program is running. Right? So as it says, you can set a breakpoint on any line, but not except for a blank line. I don't think comments work either. It doesn't make any sense, right, to do that. When the JavaScript engine encounters a breakpoint, it stops executing the statement with the breakpoint, so it does not execute that one. A light blue arrow around the line number marks the breakpoint. Maybe it is blue then. And a light blue highlight next to it allows you, if you want to step through your code. Again, you're going to see that tomorrow. As mentioned here then, the other debugging methods, how to trace the execution. There's different ways that you can do that. Already mentioned this to you. One way is to put a bunch of alerts or your own console.logs in there. Remember that if you put in console.logs, they appear in the console that's down here in your code. That can be a really nice debugging tool. What a lot of people find, and you may agree with this, you may not, but what a lot of people find is using alerts all the time, pardon my French, is a pain in the butt afterwards. Because you're constantly having this, you got to close that, and then another alert comes up. You got to close that, and then another alert comes up. You just throw stuff out into a console.log, it's just there. You can go back and look at it then. And they show an example here. So again, looks a little cleaner there when you run it with your program. So you can see, wow, it looked like this was okay. It looked like this was okay. But boy, it got, if there's an error, etc. You can tell what line is executing to where they put the breakpoint. So as it says, a simple way to trace the execution of an app is to call console.log at key points. You can also use the alert, but as I already mentioned, that can be a little pain, kind of a pain. There's other ways that you can test. There's something that's called a stack trace. People get confused about this, but you got to look at it this way. And don't worry, because this is all stuff we're going to be getting into. But if I've got a routine that calls another routine, and that routine calls another routine, there are certain things that happen, and they get put in certain areas of the computer, all right, certain areas in memory. And one of those is called the stack. And if you get an error, what it does is it unwinds everything that it's put in there, and that's called a stack trace. Now, I made it sound much simpler than it is, but in some languages, you use that a lot. All I'm trying to show you is not only is there a console.error, there's a console.warn, which will show you warnings. Technically, if you ask somebody to give you a number and they don't give you a number, technically that's an error, right? But if they give you a number less than 0, you can warn them of that, but technically they gave you a number. It might not have been a number within your range, so you might want to use a warning. All right? And there's one for tracing also. And this is the kind of thing that they're going to show you when you do a trace. I thought they showed one. Maybe, yeah, this is it. So it shows you what function called what function, etc. So a stack trace lists all the functions that the code is called up to that point, from most recent to least recent. Then they go in here. You already know this. When you come in here and you right mouse click and you choose view page source, that's what they talk about in here. And you can go in there and you can check out, we already talked about this. Go to the Elements tab and you can check out the CSS and the HTML and the DOM pretty soon. All right. And that's it. All right, 5 more minutes than I thought. Any questions on any of this? All right, then I'm just very quickly just going to jump back. And here, and here, and here, and there. So tomorrow we're going to go over Chapter 4. That'll take a good hour to go over that, get a break in there, and go through some examples. But it says how to work with JavaScript objects, functions, and events. My guess is you're going to have very little trouble with JavaScript window object, document object, text box, number, date and string. Those aren't really anything. This is where it'll get a little bit hinky, for lack of better words. We'll talk about different ways to create functions, using function expressions, using something that's fairly new called the arrow function, sometimes called the fat arrow function. We've already started talking about the difference between stuff that's with scope, and we're going to get into that in more depth. Then, depending on your point of view, this is either the neatest thing about the class so far or the worst thing. We're going to talk about how to handle events. JavaScript is sitting there. So I've got that miles per gallon program. And let's just say I've changed it, so I've got a text box there, and there's a label next to it that says, enter number of miles driven. And right next to it, I got another text box with a label that said, enter number of gallons of gas used. Then there's a button there that says, calculate your MPG. When you hit it like that, by itself, the system isn't smart enough to know what you want it to do. You have to program and tell it what you want it to do. It's going to listen, in that case, for a click event. All right, so we will go and we will look in quite a bit at those 2 different applications. All right, then we're probably going to look at 2 different iterations of a calculator. Then when you come in here again on Wednesday, I will have some kind of a pretest for you. Thursday will be lab the entire period. Friday then, and I looked at the test that they've got, and almost all of it, it says, you were just hired as a Java programmer or JavaScript programmer. A fellow programmer was fired because their stuff doesn't work. You have to fix it. And there's like a half dozen or so errors in there. They even tell you how many errors there are, and they tell you the fixes that you're supposed to make. All right. My guess is that many of you will get that done in an hour at the most. All right. So again, we'll look at these things tomorrow. All right, that should get you up to date, etc., as far as what we're going to be doing. So again, last thing,